I'd like to spend a few minutes today talking about CloudyCluster, which provides turnkey cloud HPC on the Google Cloud Platform. The first step is to create the control instance from the Google Cloud console, and this will allow you to have the web UI where you can continue creating the rest of your HPC environment. We'll start with that first. There's two ways that you can go about creating the control instance. The first way would be through the GCP marketplace. The second way, which we'll show you here, is by using the standard Cloud Console. This method is used if you had an image or you added additional software that you needed for CloudyCluster. To start, you'll need to add the prompted information, such as the name of the instance type, region, zone, and then make sure you're using the image that you created, and also select the service account that you created previously, and then finally enable HTTP and HTTP access. And then you can hit Create Instance. Once the instance is launched, then you'll want to go grab the external IP address of that instance and then paste it into the web browser. After the instance comes up, it generally takes a few minutes for DNS to propagate, as well as Let's Encrypt search to be generated for the instance. Once things settle, you'll be able to get this screen from the web browser. And with that, you can take the key that is now in your instance details, called the custom metadata, and then copy and paste that into the console, and then hit Next. Now you can enter the initial CloudyCluster username and password. This user will have administrative privileges and sudo access. Now you're ready to create your HPC environment. Now that you have your control instance in your web UI, you can proceed and create the HPC environment. The HPC environment consists of a virtual private cloud or a private network, a login instance just like traditional HPC systems, a NAT instance that allows external communications, a GCS bucket for access while processing data, a scheduler instance which can be Slurm or Torque. It also includes the CCQ metascheduler, which helps orchestrate HPC jobs based on the needs of that job. Firebase for metadata storage, and persistent disk associated with cloud parallel storage instances to provide that high throughput, high performance computing needs. I will now go through the steps of creating the HPC environment. Now from the CloudyCluster screen, select Overview and hit the plus sign to create the environment. Now you'll be prompted with options to fill in, such as the availability zone, the name of the environment, the project-wide key that you'd like to use, as well as the billing label that you'd like associated with it. Select a scheduler, Torque or Slurm, and then you can choose the environment type, small, medium, or large, depending on the number of concurrent instances you think you'll have while processing. Then you can select Quick Start or Advanced Configuration. We'll go through Quick Start just to give you an overview, but there's more advanced options that you can go and explore in the future. Next, you'll get the options to customize your HPC environment, including the name of your scheduler, the instance type, which have all been pre-filled based on the small selection we chose earlier, but you can change the mount point of your parallel file system, the total storage, the number of volumes per instance if you want to increase throughput, and also the type of volumes. Lastly, the login, instance name, as well as the instance type for it as well. Next, you will get the final summary and review, where it outlines the selections you've chose, and then also gives you the total running cost, as well as the paused cost. You have the option within CloudyCluster to pause your environment if you're not going to do computation for a while and you want to be able to come back and pick up where you left off, and that gives you the total pause cost, which is just for the storage. The last item you want to send is the network access CIDR. Then select Create Environment. Now we'll watch a sped up version of all the instances launching, configuring, and setting up everything that is needed for that HPC environment. While we're waiting for the remaining configuration, you can see that CloudyCluster also comes with over 300 packages and libraries, including standard HPC libraries and software and even ML packages that are on standard HPC systems. All of these will be ready to run once the HPC system is completed configuring. Now that the HPC environment is up and running, you want to catch the next video, which actually goes over the elastic computation using Slurm as a scheduler. See you next time, and thank you.